Hi everyone, I'm back again. Today let's try to solve LeetCode number 2833, furthest point from origin. This is an easy problem. Let's get started. You are given a string moves of length n consisting only of characters L, R, and underscore. The string represents your movement on a number line starting from the origin 0. In the ith move, you can choose one of the following directions. Move to the left if moves I equals L or moves I equals underscore. Move to the right if moves I equals R or moves I equals underscore. Return the distance from the origin of the furthest point you can get to after n moves. Okay, so this basically says that what's the problem? What's going on right here? Imagine there's a number line and you start at 0. Okay, you start at the 0. L means you move to the left, R means you move to the right, underscore means you can move in either directions, right? So in this situation, why is the answer 3? Well, imagine there's a number line, right? You move to the left 1, and then the answer to this is L, L, R, L, 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 R, right? So you move to the left once, you move to the, which puts you at -1, then you move to the left again, which puts you at -2, then you move to the right once, it puts you back at -1, then you move to the left 3 times, right? -2, -3, -4, and then the last one is an R, which puts you at -3. Well, 3, if you take a look at the absolute value, is -3. If you take a look at the absolute value, is 3 away from the origin 0. So the answer is 3, right? This one right here is 5, and it tells us that the best case scenario is L, R, L, 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 which is you move to the left, which is -1. Then you move to the right, which puts you back at 0, and then you move 5, right? 5 to the right. 1, 2, 3, 4, 5, and the answer is 5. Right here, they just give you a bunch of underscores, and so at this point, it really doesn't matter if you move to the left or the right. Either could be the answer, and so the answer is 7, right? Regardless if it's left or right. This is not a hard problem. So let's try to solve it. So I always like to take a look at the constraints. So let's take a look at what constraints we've got. 1 is less than or equal to move dot length, which is equal to n, which is less than or equal to 50. So you know that you're given 50 or less moves, and moves consists only of characters L, R, and underscore. Okay, so this is I know this is a array. This is a string problem, but I would classify this as a string problem, but they classify as an array and counting problem. Okay, so let's take a look at the algorithm design. What's going on here, right? So one thing that you notice is that, take a look at the first example, right? Let's say if we made a frequency and a count of all of our moves, right? So we know that L, we have 2 of those. We have R, we have how many of those? We have 2 of those. And then how many spaces do we got? We have, let me take a look at this, 3 of them, right? underscore, we have 3 of them, right? We have two rights. And so you notice that the left and the right moves, they cancel each other out. So 2 and 2, they cancel each other out, and you're left with 3, right? The answer is 3. Let's take a look at this second example right here. So let's do the same thing. You have L equals 2. You have R equal 1. And then you have how many of these underscores, right? 1, 2, 3, 4. Let me count that one more time. 1. Yep, you have 4. So underscores, you have 4 of these things. So left is 1, R is 1. So how can you get the answer 5? Well, the left and the rights, they cancel each other out, right? So 2 minus 1 is 1. So we know from here that 1 of the left cancels this 1 on the right, but we also have 1. We still have 1 left, right? 1 left move, and then there's 4 underscores, right? So then, which obviously are going to be all lefts, and so 2 minus 1 plus 4 would also give you 5, right? That seems like the right answer. And obviously, when you have L, when you have just 7 underscores, the answer is just 7, right? So from this situation, you can see that, there's 3 cases that we need to account for, and it's that when you have both lefts and rights, you find the maximum one of the maximum moves, whether they're left or right, and then you subtract the minimum one, and then plus adding the underscore will give you the answer, right? And in other cases, when the left and the right are equal to each other, or you just get a bunch of underscores, then you just return the value of the underscores. So this is the intuition behind the algorithm. And so let me try to write out the algorithm, right? Define left, right, and underscore variables loop through the moves for each move M. Check, not check, but figure out if it's a left, right, or underscore, and update that variable. This is to count all the frequencies, and then after this, right, then you do some if statement logic. If left is less than right, then you have to return. Well, actually, let me make a define an answer variable too. Actually, I don't even know if I need the answer variable, right? If left, then return. Yeah, I'm not sure if I even need the answer variable. Then return left minus right plus underscore, else if right is greater than left, right? No. Left is greater than right. Then you do hang on, this logic is wrong. You want to do the max minus the min, right? So this would actually be right minus left plus underscore. This would be left minus right plus underscore, and then return. In all other cases, just return underscore. You know, I really think this is the answer. Let's try it. So you have left, right, under equals 0, 0, 0. For m in moves, if m equals L, left plus equal 1, L if m equals right, right plus equal 1, else, you know that it's an underscore plus equal 1. Okay, so that gives you the frequencies of all the moves, and you store them in these three variables, right? If left is less than right, then you know that you should return right minus left plus underscore. L if left is greater than right, you should return left minus right plus underscore. Else you should just return the underscore, right? I really think this is it. Yep. All right, so that's the answer, and let me check it one more time. Not bad, not bad. You know, this is of course a time complexity of O of n problem because you're going through the moves only once, and space complexity is also O of 1, right? You're not creating any new space for anything. So, you know, this was a good problem as a review, and you know, not as a review, but it's something that you have to practice. But I think this was very good, and so for those reasons, I'm very pleased with the way that I solved this problem. Even though it's good practice. So thank you very much, everyone, and see you at the next one.